Welcome viewers. Here is the second part of our topic, sequence. In our previous lesson, we discussed the linear sequence, which is also known as arithmetic progression. Now in this lesson, we want to talk about geometric progression, which is also known as exponential sequence. So the short form of this, we use a GP. So the other one, arithmetic, that was a AP. Now here we have this. When we have geometric progression, I gave that example under the definition of a sequence. So geometric sequence, the terms of such sequence are generated either by multiplication or by division. It's either you are multiplying by a term, by a number, which is known as common ratio, or you are dividing by a number, which is also known as what? A common ratio. So suppose we have this 5, 10, 20, 40, 80, 160. Here is the sequence. And careful study of this shows that we are multiplying each term by 2. 5 times 2, 10. 2 times 2, 10 times 2, 20. 20 times 2. And that's how we generate this. So meaning this is a geometric sequence. In this case, there is a value we are using to multiply each terms, and that is 2. That is what we call common ratio. Common ratio. So we call it a common ratio. Common ratio. And how do we find common ratio? You can see this is the first term, this is the second term, third, fourth, and so on. So to get the common ratio, you divide second term by first term, or T3 by T2. That is, your common ratio equals to T2 divided by T1, which is also the same thing as T3 divided by T2, T4 divided by T3, and generally Tn divided by Tn minus 1. So that is when n equals to, and you know you don't have a zero term. So now, when n equals to 2, you have T2 divided by T1. So your n is subset of natural number. If you want to use it in this form, it means I will write Tn plus 1 divided by Tn. If I use Tn plus 1 divided by Tn, it means my n is greater than or equals to 1. And my n is a natural number. So that's how to generate the common ratio. Either you are multiplying to generate the common ratio, to generate the sequence, or you are dividing to generate the sequence. The term is the same. Example of a sequence in which the common ratio is obtained by division of, you divide the term to get the next one, is this. Suppose we have 72, 36, 18, 9, 4 and a half, same thing as 9 over 2. You can see that we are dividing this by 2. Divide by 2, divide by 2, divide by 2. Meaning our common ratio here will just be 1 over 2. Because you divide this by 2. So 72 divided by 2, same thing as 72 multiplied by 1 over 2. So meaning we are multiplying by half, 1 over 2. So when you are dividing, that will be fraction. When you are multiplying, you have it as a whole number. So we have several ways in which a sequence can be formed, especially the geometric sequence, likewise any other sequence. Then another thing to add, the nth term of a geometric sequence, the nth term of geometric sequence is given as a Tn equals to AR raised to the n minus 1, where your A is the first term, your R, as we have it before, common ratio, and your n is the number of term. Number of term. That is the nth. This is your nth term. Your Tn is the nth term. Nth term of the sequence. So this is the formula for the nth term of geometric sequence. Now let's see the application of this sequence. Let's consider this example. Find the 8th term of an exponential sequence, which is also known as what? Geometrical progression, whose first term is 5 and the common ratio is 10. So in this question, we have to look for the 8th term. So meaning you talk about the nth term of a sequence. And by definition, nth term of geometric sequence is given as a r raised to the power of n minus 1. In this question, we are given the first term of the sequence. Our a equals to 5. The common ratio is also given as 2 in this question. So first term is 5, common ratio is 2. The question says find the 8th term. It means our n is 8. So we are looking for T8. So T8 n equals to 8 equals our a, which is 2. Sorry, a is 5. R is 2. So 2 raised to the power of what? You can just use this dot. That's product. Raised to the power of n, our n, which is 8 minus 1. And this equals 5 multiplied by 2 raised to the power of 8 minus 1, that is 7. 2 raised to the power of 7, that is 128. 2 raised to the power of 5, 32. 2 raised to the power of 6, 64. 2 raised to the power of 7, 128. So that will be 5 multiplied by 128. 5 multiplied by 128, that is 640. So meaning our T8 equals to 640. And that is just solution to this problem.